Hello, today we will start our seminar and we will discuss the datasets. We are working in PyTorch framework and there we have the dataset class that we will use. At first, I want to show you different datasets that we can have in CV problems. So, the dataset for detection problem consists of images like that. Here we can see different classes: ball, robot, Raban, and there the goal. And the dataset contains the numbers that describes these bounding boxes and these images respectively. The second one, dataset for segmentation problems, is depicted here. Every pixel corresponds to a searching class. And the third one, key point detection task, the dataset for these tasks looks like here. There are points of persons, for example, that can describe the pose of an object in our pictures. Okay, as I have already said, we will use dataset class that is in Torch utils data directory. Our classes for creating datasets will be inherited from this class because we are working in PyTorch framework. So, this class requires three important methods. The first one describes our dataset, respectively. The second one, len, it contains information about the length of our dataset. We describe here how to calculate the length of our dataset. And the last one, getItem, is a function, a method that describes how we can take an element of our dataset with index. Let's create it. Okay, nice. And let's look what this dataset do. We define low number and high number, and this dataset returns us a range from low number to high number with step equal to 1. Here we will return dataset that consists of 300 numbers from 100 to 400. Let's look. Yes. Our len is 300. And let's look how getItem method works here. For example, we want to return the 10th element of our dataset. It is 110, respectively. Okay, as we have already learned, there are some parameters, important parameters that are useful for learning process. For example, batch size. So in PyTorch, we have a class data loader that describes the process of the data loading, respectively. And here we can define some parameters of learning process, for example, batch size. Yes, and here we want to have tensors which will consist of 40 numbers, respectively. What's more, we can shuffle them in arguments of data loader, yes, for avoiding overfitting. Let's look how it works. Okay, we have 7 tensors that consist of 40 numbers. Every tensor consists of 40 numbers. Yes, nice. And they are shuffled, you see? Cool. Now we will create our own dataset, custom dataset, and it will consist of different images of the balls. Let's look how we will do it. So we will use these images. At first, we need to get access to these images, so I want to mount my Google Drive disk. Connect. Cool. Here in directories, we will have another one that we'll call drive. Content, drive here. You see, it appeared. Nice. Okay, we have mounted our drive, and now we want to look at the 12 image, how we will do it. So we need a path to our data, to our image, that is defined here. We will use CV2 for working with images, and we will read this image. Then we will change color space of this image from RGB to BGR, and then we will show this image. Let's look how it works. Oh, nice. We get our image here, and that's what we want. Then we want to update our class. This class will be able for working with images, and we will name it img dataset. So it also will be an inherit from dataset, from basic class of Torch Utils data. It consists of 3 important methods too. As I have already said, it's the basic concept of this class dataset. The first one in it, so here we need to write the code that will allow us to access our data, and that's what we do here. What's more, we want to add the argument transform. We will discuss it later. And len, method len, which return the length of our dataset, and method getItem that will return our image with index that is an argument of this method. Okay, nice. Let's do it. Okay, we create our class. So here we want to take an image with index 3. Let's do it. Yes, here it is. That's how it works. What's more, for avoiding overfitting, it is cool to increase the volume of our dataset. And how we can do it in computer vision. So we can change the parameters of each picture in our dataset. This process is called data augmentation. So we want to get not only one image, we want to get a couple of images from the one. So it is able to do it with data augmentation. What's more, we will use PyTorch instruments, yes, and it is good to generate a data transform list where the transforms will be described. Okay, what we want to do. For example, we can rescale our pictures, or we can crop our pictures. The first one will change the view of our picture from CV to PIL. So, because PyTorch is used with PIL library. And the next one, we want to resize our picture with defined scaled size here. Then we want to crop the center of our picture with crop size defined here. Then we want to change view of our picture to tensor, and then we want to normalize it to change the color space, for example, for better learning process. So let's do it. We define in data transform list, as I have already said, and then we will use it a bit later. So let's look how transform to PIL image works. Yes, because we apply the first element of our data transform list. Okay, nothing changed. what will we get if we will, for example, want to apply the second element of our data transform list. Okay, all is good, no problem. Just this one. And then how we will name it, for example, him, okay? And it will be the result of the first transform here. Why it didn't work now? Because, as I have already said, PyTorch is used with PIL library for computer vision. So the first view of our pictures are in CV library, and then we need to transform it to a PIL. Nice. It works. What will we get if we, for example, apply third filter? Oh, just a moment. I want to show him. Here, nice. Nice. And the first one, the resize here. Cool. And the last one will work after we will change the view to tensor view. That's why we want to do it like this. To PIL library, then to tensor. Data transform 3. And then to normalize it, for example. Here. Okay. Center to tensor. Okay. So then I want to tell you about the compose method that apply all these transforms from transform list. So let's look at the result of these columns. Nice. You see the resulting image change the color space, and it is because the normalize transform was used here. Let's look the raw picture here. Let's look this one. Okay, nice. Let's go further. We are creating the dataset, yes, with the class EMG dataset here, yes. And then we want to look at, for example, the one of these images in this dataset. Okay, the fourth image, the image with the fourth index. What more we can do? For example, we can rotate our picture, yes? And it is used with the method random rotation. Let's look how it works. Nice. You see, our picture rotated here. What more, we can do not only rotation, we can do random rotation, yes? This filter will rotate our image with in a random way. And here we define range of these rotations. Then we can, for example, do random cropping, yes, with this range. And what's more, we can do random horizontal flip. At first, we create our data augmentation list that consists from these 3 filters, and then we can apply it to our image. Nice. Here we can see the result of rotation. And for example, we want to random crop. How we will do it? We will apply the second filter. Nice. Okay, random crop was... Okay, and sorry, here. I should change it here. You see, we get the result of our cropping. And if we want to do horizontal flip, we need to do it like this. Okay. What's more, we can change the color space of our pictures. We can change brightness, for example, in range from 0.8 to 1.2. Let's look how it works. So here we get different views of our raw picture, and it allows us to increase the volume of our dataset. So compose like this, it will apply all these filters that are right in here. Let's look at the result. Here we can see the result of rotation, the result of cropping, and maybe a result of random horizontal flip. So all this method helps to increase the quality of learning process. It increases the volume of dataset, and after that it becomes possible to avoid overfitting. What's more, as we have already said, we can split our data into 3 groups: the training set, validation set, and testing set. We can do it in PyTorch with function random split. With using random split, we can split our dataset respectively. The first argument is our data, and the second one, the list of our percents. For example, here, 80% of our dataset will belong to training set, 10% will belong to validation set, and 10% will belong to test set. So let's look at the results of this splitting. Okay, nice. What's more, there are a lot of datasets in net that are used in computer vision tasks. So, for example, COCO dataset, it consists of more than 300,000 images, and it has pictures for key point detection, for multi-object detection, captioning, and segmentation, mask annotations. So there are 80 classes and 5 captions per image. The next one, Cityscape dataset, it is used in, for example, self-driving cars technologies. So it looks like this. It contains 30 classes, 8 different categories, 5,000 annotated images with fine annotations, and 20,000 annotated images with coarse annotations. CIFAR10 is the dataset 2. It consists of 10 classes and about 60,000 color images with 32 by 32 resolution. So, and the last one, I want to say, MNIST. It contains handwritten digits and the training set consists of 60,000 examples, and test set consists of 10,000 examples. It looks like this. So that's all I wanted to say. Thank you for your attention.